All right, everyone. So in chapter 7 in Calc 2, most of the chapter is about finding integrals or finding antiderivatives of certain functions. But it's not comprehensive because some of it you're expected to already know from Calc 1. So I just want to make this quick video on some antiderivatives or some integrals that you need to know when you come into a Calc 2 class. So I'm not going to explain why the answers are the way they are. If you want to know that, you can come talk to me. But I'm just going to just briefly go over the rules, and probably most of you know all these rules already, and if you don't, I wanted to make a little video so that way everyone could be on the same page and everyone can know the rules. Okay, so the goal of this video, just to give you some simple antiderivative rules that probably you already know. Okay, so just real quick, some notation. When you see something like this, I'm asking you to find, well, there's two ways to say it. One way is, I'll just say integral, which it means indefinite integral. There's also such a thing as definite integral where there are numbers on the integral sign. But today we're talking about indefinite integrals. So no numbers here. So nothing here, nothing here. Then you just have this symbol, and then there's a dx. And basically when you see this symbol here, which looks like an elongated S, and you see this dx here, I'm asking you to find all of the antiderivatives of the function that's in between here. So whatever function is given here, your job is to find all of the antiderivatives of that function. Okay, so I'm not asking you for one function, I'm asking you for all the antiderivatives. So basically what you're going to do is you need to find a function whose derivative is this, and you would write that answer here. So whatever function you come up with. So the derivative of this needs to be this. And then you're going to put a plus c, because there's a theorem that says once you've found one antiderivative, if you want to make a list of all of them, it's just going to be this one plus some constant. So you put plus c, and then if you put any number here for this c, you get another antiderivative. Okay, so antiderivative, indefinite integral means the same thing, except indefinite integral, I want all of the antiderivatives. Okay, I want to find all the antiderivatives between this symbol and this symbol. Quick example. Okay, you know a function whose derivative is 2x. Okay, by the way, one thing we want to pay attention to is going back and forth between when I say derivative and when I say antiderivative. So this video is about antiderivatives, but first let me just ask you, can you think of a function whose derivative, not antiderivative, derivative is the function they gave you here, 2x? And you sit and think for a minute and you go, oh yeah, x squared. Okay, so you know that the derivative of x squared, so here's x squared. If you take the derivative of it, you get 2x. Okay, so since the derivative of x squared is 2x, the antiderivative of 2x is going to be x squared. But I don't just want one antiderivative, I want them all. This is the only example where I didn't actually put the notation in, because this is another way I wanted to show you that they could ask the question. They can ask you to find the most general antiderivative. It sounds like they only want one answer because they use the word the. Usually the word the means just give me one. The most general antiderivative means give me all of the antiderivatives of the function they gave you. So I didn't put the notation in the question, but if I wanted to put the notation for the most general antiderivative of 2x would be written like this. So you have this symbol here, 2x dx, and I'm asking you, so to calculate this, I'm asking you, tell me not one, but all of the antiderivatives of this. And the way you do it, you give me 1, which you know is x squared, and you just put a plus c at the end, and that's a list of all possible antiderivatives. So again, the c stands for a number, so x squared plus any number is another antiderivative of 2x. For example, if you change the c here to 5, you get x squared plus 5. If you change the c to 0, you get x squared, because it's x squared plus 0. If you change it to like a negative number, like 3, you get x squared minus 3, x squared plus negative 3, or anyway. But any other number here, so each one of these is an antiderivative of this. In other words, if you take the derivative of any of these, you get that. So you just make the list of all possible antiderivatives. Okay, another example. Antiderivative cosine. So you have to think to yourself, what do I know about trig functions? Your job right now is to come, I'm not asking you to take the derivative of cosine. Be careful here, okay? I'm asking you, give me a function whose derivative is cosine. Okay? And you think about it for a minute and you realize the answer is sine. I know I have to put a plus c, but give me a second here. Just to check your work, if you took the answer here and took the derivative, then you should get the function that they gave you in the integral symbol here. So this is your answer, and it's right because the derivative of the answer is this function here. The derivative of sine is cosine. But again, of course, you got to find all of them, so you put a plus c over here. Okay, so we're just going to go over a few rules. And again, memorize the rules. If you want to know where they come from, we could talk about it some other time. Okay, so let's take a look at these 3 rules. Actually, there's going to be a 4th one, but there's 3 on this slide. So, okay, the first one, k stands for a number in what I have here. And basically what I'm saying here is that if you want to take the antiderivative of a number, you just take the number and tack on an x, and then put plus c. I mean, for example, you know the derivative of 5x. What's the derivative? The answer is 5. So if I ask you to find the antiderivative of 5, okay, so I'm going backwards, antiderivative of this, the answer is 5x. Basically, you take the 5, and you tack on an x at the end, and then don't forget to put plus c. So this is the first rule to memorize. If you're taking the antiderivative of a number, what do? It's the number times x plus c. Okay, the second rule that's on this slide here says, what if you want to take the antiderivative of a number of x to a power? So the function we're finding the antiderivative of is x to a power. It's very important that there's an x as the base and the power is a number. That's very important. So let me just write here that this has to be x. The base has to be x. The power has to be a number. Okay? If the power is not a number, or the base is not just x, do not use this rule. Okay, so x to a power. And this will work for any power except for when the power is -1, and we'll talk about that in a second. But if the power is anything else besides -1, here's what you're going to do. So here's the thing. When I give you a rule, sometimes I'm going to say it in words, and it's really a good idea for you to say it in words exactly the way I say it. I mean, you might have some other ways to remember it, but a lot of times I'll pick a way of saying it that makes it easy to remember. And if you're like, but I know I have an easier way. Well, there might be a reason why I picked it a certain way. Not just to make it easier, but also because it just helps in certain situations. So here's what I'm trying to tell you. If you're trying to find the antiderivative of x to a power, you're going to write down the x. Okay, so you're going to copy down the x. And first thing you want to do is change the power. Increase the power by 1. So whatever the power is, add 1 to it. So if the power is 5, make the power 6. And then after you've added 1 to the power, divide by that new power. So do it in that order. So copy the x down, add 1 to the power, then divide by the same power. And then after you do that, of course, don't forget to put the plus c. So just a real quick one, even though we're going to do more. If I say, what's the antiderivative of x to the third? You know, you copied, so you write down x, change the power to 4. Okay, so first, make sure you do that first. Increase the power to 4, then divide by the new power, and then, of course, plus c at the end. That would be the answer for something like that. Okay, and that rule works for any power. Again, this doesn't even have to be a whole number. Okay, it could be a negative power, it could be a fraction, anything. But the power can't be -1. Let me just tell you real quick why it can't be -1. Well, you can see from the formula here that if n was -1, you'd end up with 0 down there. If you plug in -1 here, -1 plus 1 is 0. Or if I just show you with this little integral symbol over here. So if I was finding the antiderivative of x to the -1, and you tried to use this rule, you would have to add 1 to the power would be 0, so you'd first change the power to 0, then you divide by 0, and you cannot divide by 0. Okay, so this is very bad, because you can't divide by 0. So just when the power is -1, we're not going to be using this rule. This rule is true for any other power besides -1. So what if it's -1? I mean, I still want to know how to do it if the power is -1. Just can't use this rule. But here's the deal. X to the -1 is the same thing as 1 over x. I haven't found an antiderivative. I just rewrote it. X to the -1 and 1 over x, those are the same function, 1 over x. And so I'm giving you the rule for that one separately over here. Okay, and this is a very important one to memorize. And again, I'm not deriving it or anything. Just memorize it. Antiderivative of 1 over x. The answer is natural log of absolute value of x. Don't forget the absolute value. So a lot of people write natural log of x. Please put the absolute value around the x. Not around the whole thing, just around the x. So it's natural log absolute value of x, and then plus c. Okay, here's a 4th one. Okay, so this is the antiderivative of an exponential function. let's please make sure that you're clear. Let's write this down first. So go ahead and take a look at this real quick. I don't want the answer. Just look at that, and then look at that. I want to make sure it's crystal clear that these are totally different kinds of functions. Here, the function we're finding the antiderivative of, the base is x, the power is a number. Okay, so that's the one that we just used, the rule that I just gave you, which is called the power rule, where you add 1 to the power and divide by the new power. Now look at this one. The power is not a number. This time the base is a number and the power is x. When it's like that, it's called an exponential function. So this is just x to a power. This is an exponential function. Okay, so when I say x to a power, I mean x and the power is a number. Here, exponential function, the bottom is a number, the base is a number, and the power is x. For an exponential function, the rule is totally different. So please, if I ask you to find an antiderivative something like this, don't be adding 1 to the power. Sometimes when I ask this kind of question, a student they'll use the power rule. So they'll write 2 and they'll add 1 to the power and they'll write x plus 1. When you add 1 to the power should be a number if you're using that rule. So don't be doing something like this and then they'll divide by that new power. This is way wrong. Please don't do that. Plus c, whatever, it's still wrong. Okay, so when the base is a number and the power is a letter, that's an exponential function. And then the rule for the antiderivative of an exponential function, again, I'm not showing you where it came from, but here's the answer. You just copy down that same exponential function and you divide by natural log of the base. Don't let the bottom scare you. That's just a number. It's natural log of the base, and the base is some number, and then plus c. So let's go ahead and actually do these 2 problems that I have written down here just for fun. So for this first one, because the base is x and the power is the number, you can use that rule where you add 1 to the power. So you write down x, you add 1 to the power, becomes 3, divide by the new power, and then plus c. Whereas for the second one, it's an exponential function. To find the antiderivative exponential function, you just copy down the whole entire exponential function, divide by natural log of the base. The base is 2, so divide by natural log 2, and then plus c. That's how that one goes. Okay, so that was 4 specific rules. How do you find the antiderivative of a number? Tack on an x. How do you find the antiderivative of x to a power where the power is a number? You add 1 to the power, divide by the new power. Antiderivative of 1 over x is natural log absolute value of x. And the antiderivative exponential function, you copy the exponential function down and divide by natural log of the base. For all of them, don't forget the plus c. Those are 4 specific rules. Okay, now we're going to talk about general rules. See here, I haven't told you what function I'm talking about, but these are very important. When you take Calc 1, you learn how to find the derivative. I'm saying derivative now, not antiderivative. You learn how to find the derivative of everything. You learn how to find the derivative when you're adding. You learn how to find the derivative when you're subtracting, when you're multiplying, when you're dividing, when you're composing, when there's a number in the front. There's all sorts of situations. Basically, you know how to find the derivative of everything. But antiderivatives are going to be important to us in Calc 2. And so I want to be able to find the antiderivative of everything. And I'm just going to tell you right now, we're not going to be able to find the antiderivative of everything. In other words, how do you find the antiderivative of any function I can throw at you? We're not going to be able to do it. For any function I could throw at you, what's the derivative? Just derivative, not with the word anti in front of it. What's the derivative? We're going to be able to find it. No problem. There's rules for everything. For antiderivative, there isn't rules for everything. And that's kind of what the problem is when it comes to this chapter 7 on antiderivatives. Well, it's like, if we can't find the antiderivative of everything, what can we find the antiderivative of? Well, first of all, from Calc 1, we need to borrow these rules. So these 3 rules. The first one is, how do you find the antiderivative when you're adding functions? The second one, when you're subtracting functions. And the third one is, what if there's a number in front of the function and you're trying to find the antiderivative? Once again, I'm going to say these a certain way. Make sure you say them this way to yourself. It's going to really help. And again, if you have another way to do it, just try it. You'll have 2 ways. Otherwise, really say it the way I'm about to say it. So basically, this rule says if you're taking the antiderivative of a sum, you take the antiderivative of each piece separately. So just say separately. You take the antiderivative of this function and this function separately. Of course, since there's an addition here, there's going to be an addition here when you're done. Okay, but when you take the antiderivative of sum, what do? Antiderivative of each piece separately. Okay? Same thing when you're taking the antiderivative and there's subtraction going on. you take the antiderivative of each piece, so this piece and this piece, separately. That's what it says there. And again, since you have a subtraction in the middle, you're going to put a subtraction there. Okay? So one more time, let's go over those two. If you find the antiderivative of a sum, what do? Take the antiderivative of each piece separately. What if you're taking the antiderivative and there's subtraction going on? Take the antiderivative of each piece separately. Before we go on to the third one, make sure you understand, if you're taking the antiderivative of a product, like instead of addition here, let's say there was multiplication, how do you do it? Some students, until they get it, if they're confused, they're going to take the antiderivative of each piece separately. You cannot do that. This separately business only works for addition and subtraction, and that's it. Okay? Even when it came to regular derivatives, how do you take the derivative when there's multiplication going on? You're supposed to use the product rule. Now, it turns out there's no product rule for antiderivative, so we're going to have to figure out something else. Okay, so that's why I'm not giving you a rule for that right now. Okay, so one more time. For antiderivative of a sum or antiderivative of a difference, take the antiderivative of each piece separately. But if it's multiplication or division or anything else, besides that addition or subtraction, do not take the antiderivative of each piece separately. Okay, for this third one, I'm going to say it one way, and please, everyone, say it to yourself that exact way. It's just going to make life easier. So here's what it says. If you're going to take the antiderivative of a number times a function, what you do, again, we're going to say it like this. What you do is you copy the number down. So K stands for a number. Copy the number down, and then take the antiderivative of the rest. Okay, so one more time. If you're taking the antiderivative of a number times a function, you copy the number down and then take the antiderivative of this. Copy the number down first, then take the antiderivative of the rest. I know there's other ways to say it, like you can pull the number out, all that, but let's at least be able to say it that way. Copy the number down and then take the antiderivative of the rest. Okay, so we learned 4 rules so far for antiderivatives, and we learned these 3 general rules for how do you deal with addition, subtraction, and a number in the front. And again, I'm not giving you rules for the other ones, like what if you're multiplying, what if you're dividing, and what if you're composing. So we're not going to talk about that in this video, but some of that will be addressed in chapter 7. Okay, and then what else? What other things are we going to be able to take the antiderivative of? So anytime you know the derivative of a function, you know the antiderivative of another function. So for example, you may know from Calc 1 that the derivative of tangent is secant squared. So if you go this way, you're taking the derivative. And so, therefore, the antiderivative of your answer is the original thing. So, antiderivative. So let me just say it again. So the derivative of tangent is secant squared. So the antiderivative of secant squared is tangent. Don't forget the plus c, of course. Okay, but again, anytime you know the derivative of a function, whatever your answer is, you know the antiderivative of the answer. It's the question. And then plus c. So, you got to know a lot of derivatives. You should have a lot of derivatives memorized. I'm going to show you a couple of slides. I'm going to give you some stuff that definitely you should have memorized. Let's talk about trig functions real quick. Here are the rules for antiderivatives of trig functions. I'm sorry. These are the rules for derivatives. Derivatives of trig functions. So therefore, you can go backwards on any of these rules and get the antiderivative. So for example, the very first rule here says the derivative of sine is cosine. So what does that tell me? If I take the antiderivative of which one? The answer, cosine. You get, oops, I forgot the dx. Please don't forget the dx. So the antiderivative of cosine is sine. And again, plus c, don't forget the plus c. Okay, another one, if I said, what's the antiderivative of secant squared? Well, you see from this rule, if you had it memorized, again, the derivative of tangent is secant squared. So therefore, the antiderivative of secant squared is tangent. And of course, don't forget the plus c. Now, let's be careful on this point here. I am not telling you that we know right now how to find the antiderivative of all trig functions. Like, what's the antiderivative of tangent? Well, as far as what this video is talking about, we don't know the answer. When it comes to u substitution, we'll be able to find the answer. All I'm trying to say is, since you know derivatives of functions, we know antiderivatives of other ones. So this slide helps me figure out the antiderivative of each of the answers. Okay, so each of these things we could find the antiderivative for, and the antiderivative will be whatever the question was. Okay, so whatever's circled, we know the antiderivative of. Okay? Not the original problems. Like, what's the antiderivative of cosecant? Well, we haven't talked about that. Okay? But what's the antiderivative of negative cosecant cotangent? It's cosecant x plus c. Okay? So in particular, you know the antiderivative of sine and cosine, but tangent secant squared, we don't know the antiderivative. I'm sorry, tangent secant, we don't know the antiderivative of those things. Secant squared, of course, we do know. I guess I should mention, whenever you have a negative, like if I want the antiderivative of just sine and I don't want the negative sign, you can put the negative sign over here. Because, for example, you know that the derivative of cosine is negative sine. But what if I wanted the antiderivative of just sine? Couple ways to do it. But let's just do it like this. What's the derivative of negative cosine? Just as it is for antiderivatives, when you have a number in the front, you could think of this as a number in the front. You copy it down and then take the derivative of the rest. The derivative of that is negative sine. And those negatives cancel and you get positive sine. So you can see the antiderivative of positive sine is negative cosine. So the antiderivative of positive sine equals negative cosine. Of course, don't forget the plus c. Also, in class, when I ask these questions, students usually get them backwards. So try not to get them backwards. Memorize that the derivative of sine is cosine. The derivative of cosine is negative sine. But it's backwards when it comes to antiderivatives. For example, the one that I just wrote, the integral that I just wrote down about the integral of sine, this one here, a lot of students might say the answer is cosine. You're getting derivatives and antiderivatives confused. The derivative of sine is cosine, but I'm asking for the antiderivative. And basically how it works for sine and cosine is just the sign, the SIGN sign of the answer just goes backwards when you go from one to the other. Okay, so you thought that, you know, the derivative of sine is cosine, but the antiderivative is going to be negative cosine. Same thing when we're talking about cosine. You know the derivative of cosine is negative sine, but what's the antiderivative of cosine? It's not going to be negative sine, it's going to be positive sine plus c. And so you also see in this way that the more derivatives you know, the better, because that means the more antiderivatives you know. Because again, I want to know the antiderivative of everything, and since I can't know the antiderivative of everything, I want to know the antiderivative at least of as much as possible. So what other derivatives do you know? So these are the rules for the derivatives of inverse trig functions. Now, again, the more you have memorized, the better. And I'll just tell you, I'll be honest with you, that for me, I have these three memorized. You should, I mean, again, it'd be wonderful if you have all six memorized. But I have those three memorized, and then the rest of them, if I forget, I'll look it up in a table or something. I guess the important thing is, if you're not going to memorize them all, at least get an idea of what the answers look like. So if you have, if you're asked to find the antiderivative of something like this, you go, oh, that's probably an inverse trig function. Let me go find the inverse trig function answers. And once again, since we know derivatives, we know antiderivatives. I changed notation on you here, but this symbol, ddx, means take the derivative of whatever is after it, and sine x is after it. So this is saying the derivative of sine inverse, sorry, I said sine x, sine inverse of x is this. Therefore, the antiderivative of this is the original question. So, for example, the antiderivative of 1 over square root of 1 minus x squared is going to be sine inverse. And of course, you want to write all of them down, so you put plus c. Okay, another example is something like if I say, what's the antiderivative of 1 over 1 plus x squared? Well, we know the derivative of tangent inverse is 1 over 1 plus x squared. So the antiderivative of 1 over 1 plus x squared is tangent inverse. Right, and then so on. So again, the more you have memorized, the better. So the idea is when you see something like this, I want you to just recognize, oh, that's an inverse trig function. And if you know it's tangent inverse, great. You know, worst comes to worst, you're like, well, I know it's some inverse trig function, you can look it up. Okay, so that's how those go. Let's talk about hyperbolic functions. They look like sine and cosine, but they have an h. So hyperbolic sine, hyperbolic cosine. And again, I'm not going to show you where these formulas come from. I'm not going to tell you what hyperbolic functions are. But if you've heard of them, then we have these 6 rules. Just like there's 6 trig functions, there's 6 hyperbolic trig functions. And so, for example, the derivative of hyperbolic sine is hyperbolic cosine. So what does that mean? If you take the antiderivative, if you want to take the antiderivative of the answer, hyperbolic cosine, you're going to get hyperbolic sine. So real quickly here, the antiderivative of hyperbolic cosine is hyperbolic sine. And of course, you're going to put the plus c at the end. Another one, if you wanted the antiderivative of, let's just say, hyperbolic secant, hyperbolic tangent. Well, we actually don't have one of those here, but we do know that the derivative of this is negative hyperbolic secant, hyperbolic tangent. So I know the antiderivative of negative hyperbolic secant, hyperbolic tangent is hyperbolic secant. And so what do I do with this negative sign here? Since the negative sign is not there, you can just throw it over there. And so the answer to this one is negative hyperbolic secant plus c. So you see, again, the more derivatives you know, the more antiderivatives you know. You look at this and you go, oh, well, secant tangent, hyperbolic secant, hyperbolic tangent, that looks like the answer to some derivative of a hyperbolic function. And you can go back and look it up. You can also use the trig functions to give you an idea. If you have the trig ones memorized, you know the derivative of secant is secant tangent. So you might guess that the derivative of hyperbolic secant is hyperbolic secant, hyperbolic tangent, and you're close. Just there's this negative sign. So it gives you an idea. So the answer wasn't secant, hyperbolic secant, but it has this extra negative sign. Okay, so again, more derivatives you know, more antiderivatives you know. And here's another list of the derivatives of inverse hyperbolic functions. And we get this list, and it looks similar, but they're not exact, but similar to the derivatives for inverse trig. So there's trig and inverse trig, and there's hyperbolic and inverse hyperbolic. And the derivatives for hyperbolic and inverse hyperbolic look similar to the derivatives for trig and inverse trig. For example, if there was a minus here in this first formula, and one of the antiderivative would have been sine inverse. But what if you have a plus? I don't want you to be like, oh, then we don't have the answer. We do. Turns out to be hyperbolic sine inverse instead of regular sine inverse. So a lot of these formulas will look the same as the inverse trig ones. Just you might have a sign change, like instead of a plus, a minus, that kind of thing. Okay, so just real quick again. Since we know the derivative of sine inverse, hyperbolic sine inverse, is this 1 over square root of 1 plus x squared, the antiderivative of 1 over square root of 1 plus x squared is this hyperbolic sine inverse. Okay, so the antiderivative of 1 over square root of 1 plus x squared is hyperbolic sine inverse. Don't forget the plus c. And one more real quick. If I wanted to know the antiderivative of 1 over absolute value of x, square root of x squared plus 1. Again, you see that right there is the answer when you take the derivative of this, except of course the minus sign, so we're just going to have to throw the minus sign. You can just move the minus sign around, because remember, the minus sign is like a number in the front. So what we do with the number in the front, you copy it down. So we can kind of just throw it over there, and the answer to this would be, again, if the negative sign is not here to begin with, then you're going to go ahead and put it here in your answer. So negative hyperbolic cosecant inverse. And of course, plus c. That's how that goes. Okay, let's go over the rules real quick. Okay, so I'm calling this antiderivative quickies. What's the antiderivative of 5? It's the antiderivative of a number. What do you do to find the antiderivative of a number? Tack on an x. So it's going to be 5x plus c. Let's do another one. The antiderivative of negative 7. Again, the antiderivative of negative 7. Negative 7 is just a number. How do you find the antiderivative of just the number? Tack on an x. And then don't forget to put a plus c. So you write negative 7, tack on an x to it. Multiplication, of course. So it's that number times x plus c. Another one. The antiderivative of e. This confuses people sometimes because it looks like an exponential function, but it's not. They're trying to trick you. Why are they trying to trick you? Because it just says e. It doesn't say e to the x. That would make it an exponential function. So you're used to seeing e to the x, but this is just e. And e is just the number. So once that antiderivative of just the number, you tack on an x. So it's e. It's not e to the x. It's e times x and then plus c. Okay, so that's some practice with antiderivatives of numbers. Okay, now let's go to antiderivative of x to a power. So if I want the antiderivative of x to the fourth, what do? Again, copy the x down, and then add 1 to the power, then divide by the new power. So So when you add 1 to the power will become 5, and then you divide by the new power, which is 5. So it's going to be x to the 5 over 5, and then just add c. Okay, another one like that. Antiderivative x to the 1/2. Again, this is x to a power. And the power is a number. Okay, remember, it has to be x on the bottom as a base, and the power has to be a number. Then how do you find the antiderivative? Write down the x, add 1 to the power. If you add 1 to 1/2, you get 3/2. And you divide by the new power, 3/2. So it becomes x to the 3/2 divided by 3/2, and then plus c. I know that could be simplified, but I'm not going to worry about the simplifying right now. Let's do one more like that. Antiderivative x to the -7 over 5. Again, x to a power, right? And the power is a number, so what do? Add 1 to the power and divide by the new power. If you add 1 to -7 over 5, you get -2 over 5. So you get x to the -2 over 5 divided by -2 over 5. Don't forget the plus c. And then, of course, we can simplify that later. Okay, what about the antiderivative of 1 over x? Memorize that one. And the answer is natural log absolute value of x. And then don't forget the plus c at the end. Okay, let's see if this tricks you. Antiderivative x to the -1. Don't let this trick you. How would it trick you? If you try to add 1 to the power and divide by the new power, you can't do that rule if the power is -1. But just realize that x to the -1 is the same as 1 over x. So I asked you the same question. I just wrote the power different. I just wrote the function instead of 1 over x. I wrote it as x to the -1, but they're the same. So it's the same question. So it's going to be the same answer. Okay, natural log absolute value of x plus c. Okay, let's take the antiderivative of e to the x. That's an exponential function because now the base is a number and the power is x. Now e to the x is a special one. The answer is just going to be itself. But if you use the rule I gave you, the good thing about the rule I gave you is that it works all the time, no matter what the base is. So if you use the rule I gave you, I said for an exponential function, you copy the exponential function down, you divide by natural log of the base is e, then you do plus c. But natural log of e is just equal to 1. So we have e to the x over 1, so it's just e to the x. So e to the x is probably another separate one you want to memorize. You don't have to write the natural log e because it just goes away. So it's just e to the x. Okay, so just memorize that. Okay. Or you can use the rule, it's just an extra step. But okay, antiderivative e to the x plus c. But if it's a different base, so if the base is something like 5, so 5 power x, that's an exponential function. What's the antiderivative of an exponential function? You copy the exponential function down. So we're going to copy down 5 to the x. We're going to divide by natural log of the base, so natural log of 5. And so you get 5 to the x over natural log 5 plus c. Okay, one more. This is also an exponential function. Remember, exponential function has a number for the base. In this case, it's pi. And then the power is x. And again, to find the antiderivative exponential function, you copy it down and divide by natural log of the base. So you're going to copy down the pi to the x, divide by natural log of the base, plus c. Okay, let's do a couple more problems. Okay, so this problem is asking you to find the antiderivative of this stuff. And one thing I want you to notice is there's a lot of addition and subtraction. We have subtraction, addition, subtraction, addition, addition, subtraction. So the very first thing is you're going to find the antiderivative of each piece separately, because that's the rule when you're adding and subtracting. Find the antiderivative of each piece separately and then add and subtract them. We also have some numbers in the front, like this 12 is a number in the front, this 8 is a number in the front, this 5 is a number in the front. This 9 can be thought of as a number to the front. But also you want to be clear how you write things. So let me just give you some advice. Don't find the antiderivative of some parts and not other parts. For example, you might get real excited and find the antiderivative of this in the first step. But then when you get to something like this, you're going to say, oh, I don't know the answer yet because I need to rewrite this. You're going to rewrite the square root of x as x to a power. So we can use the rule when it's x to a power. Okay, so you don't want to do that because then if you write the antiderivative of this, but you just rewrite this, you don't write the antiderivative of this, then whatever you write in your answer, in your next step, it's not going to have any meaning. It's not the antiderivative. It's not the original function. What is it? It's a tangled up mess. So here's my advice. First step, if you need to rewrite any parts of the function before you take the antiderivative, rewrite them. So rewrite parts of the function, copy down the rest, don't take any antiderivatives yet. And then when you're ready, go take the antiderivative of each piece one at a time separately. So First thing I'm going to do is I'm going to rewrite everything. Anything that needs to be rewritten, I'll rewrite. And if it's already written in a good form, I'll just copy it down. So notice I'm going to put the integral symbol here, okay, because I'm not taking the antiderivative yet. 5x squared is written fine. I don't need to do anything there, so I'm just copy it down. 8x is fine. 3 is fine. But again, when it comes to this root, we're going to rewrite it. You know, square root of x is the same thing as x to the power 1/2. And when you write it as x to a power of a number, we have a rule for that. Plus, okay, this 9x over x to the third. First thing you need to understand is we don't have a rule for division. Okay, this is division right here. So don't take the antiderivative each piece separately. Please do not do that. You're going to rewrite it so that we can use the rules we already have. So here's how I'm going to rewrite this. I'm going to put the 9 in the front because we know how to deal with numbers in the front. So the 9 goes here. What's left? It's 1 over x to the third. And I don't like that the x to the third is on the bottom, so I'm going to bring it up. If you have something on the bottom and you want to bring it up, you just change the sign of the power. So it becomes 9x to the negative 3. And now it looks just like, for example, this. It just has a negative power. Okay, then plus. Now the 1 over x. Here's a situation where you don't want to bring it up. Why? Because we know the antiderivative of 1 over x. That was that special one. And if you bring the power up, you might accidentally use the rule for x to a power when you're not allowed to use it on that one. So just leave that one alone. It's ready to go. I know the antiderivative of that. And minus, and now secant x tangent x. Okay, secant x tangent x is multiplication. There's multiplication going on here. So what do you do when there's multiplication? Do not take the antiderivative of each piece separately. You don't do that. When do you take the antiderivative of each piece separately? When there's addition and subtraction only. So what do you do? Well, the answer is, I know a function whose derivative is that whole thing, secant x tangent x. So we're just going to use that information. And so I'm just going to go ahead and copy it down. It's fine. I don't need to rewrite that one. Okay. So I want you to notice in this first step, I just rewrote the entire thing. I put the integral sign again. Okay, I put the dx again. I didn't take the antiderivative of anything. I just either copied things down or the ones I needed to rewrite, I rewrote first. So just those two. Okay, and everything else I just copied down. Now at this step, I'm going to find the antiderivative. When you find the antiderivative, you're not going to write this symbol anymore. You're not going to write the dx anymore. You'll find the antiderivative of each piece separately. And don't forget at the end, you need to put a plus c. All right, this is getting messy. Let me erase a little here. Okay, so now, antiderivative of 5x squared. Well, there's a number in the front. What do you do when there's a number in the front? What do you do with the 5? Well, you copy it down. Remember, say it like that, okay? Copy the number in the front down, and then you take the antiderivative of the rest of this part. And what's that antiderivative of x to a power when the power is a number? You add 1 to the power, and you divide by the new power. Okay, minus. Now the next term. Again, what do you do with the 8? It's a number in the front. You copy it down. And then you take the antiderivative of the rest. That's x to the power 1. Think about it like that. So you have to add 1 to the power. It becomes x to the power 2 over 2. Plus onto the next term. This is just the number. Antiderivative of 3. You tack on an x, 3x. Next term, minus. Again, number in the front. Copy it down. So you copy down the 12. And then antiderivative of x to the 1/2. Again, it's x to a power. The power is a number. You write down the x. You add 1 to the power. It becomes x to the 3/2. And you divide by the new power, 3/2. Plus, next term. Again, we have a number in the front. So copy it down. Copy down the 9. And then you take the antiderivative of this. And again, it's x to a power. The power is a number. It's negative. So what? So you write down the x. Add 1 to the power. So the negative 3 becomes negative 2. So you have to add 1, okay? Negative 3 plus 1 is negative 2. Then you divide by the new power, negative 2. And then next term, 1 over x, the antiderivative of that is natural log absolute value of x. Okay, next term. What is the function whose derivative secant tangent? It's secant. So you have that one memorized. The derivative secant is secant x tangent x. So secant x is the answer there. And don't forget the plus c. And then the last step I'm going to do is I'm just going to clean things up here. So the first term, I'm just going to move the 3 over next to the 5. You don't have to do that, but just to clean it up. Next term, the 8 and the 2, you can divide those and get a 4. So it's 4x squared plus 3x. This next term here, you're supposed to flip this 3/2. It's going to become 2/3. So it's minus 12 times 2/3. I guess I'm going to have to do another step. But you get that. Then over here again, I'm going to take this -2 and just move it under the 9. It's going to become minus 9/2. And while I'm at it, I'm going to move the x to the -2 down so the power is positive. So I'm just put 2x squared on the bottom there. All I'm doing is cleaning things up. This is not calculus anymore. It's just simplifying. Okay, and we get that. I'm going to do a little more cleaning up. But let me just go over the process one more time. First step, rewrite the function if you need to, so that you're going to be able to find the antiderivative of all the pieces. Don't take any antiderivatives in that step. Then in the next step, take the antiderivative of each piece, all of them. Do all antiderivatives at once. Okay, one more time. Don't take the antiderivative of some parts here and some other parts here, because then what you write over here is not going to mean anything. Okay, and then the last thing you do, you clean it up. So we clean it up, we get this. And the last little bit of cleaning up I'm going to do, I'm just going to clean this part up. What is 12 times 2/3? I think that's 8. So, okay, a lot of erasing to do over here. Okay, so yeah, 12 times 2 is 24. 24 divided by 3 is 8. So let me just put an 8 there. And we'll call it a day on that one. Okay, let's try the next one. Okay, for this next one, again, I want you to notice that there's a lot of addition and subtraction. The subtraction, addition, addition, subtraction. So we're going to take the antiderivative of each piece separately. That's what you do when there's addition and subtraction. And then if any of those pieces, I don't know the antiderivative right away, I'm going to rewrite it. The only one I don't know actually is this one, just because the 3 is there. If there was a 1 here, then that's going to be some kind of inverse trig function or something. But there's a 3, so what I'm going to do, I'm just going to put the 3 in the front, so it's like a number in the front. So it might seem like a little bit of a waste because I'm going to write a whole bunch of stuff down just to rewrite one little thing. But I want to make sure I write it correctly. So antiderivative symbol, I'm not taking any antiderivatives yet. I'm rewriting the function, and again, basically every term is going to get copied down. And this one, we just put the 3 in the front like that. You don't actually have to do that either. If you can just visualize that that's what it is, then you can go right on and take the antiderivative. But just so you see what's going on in my head, I'll write this step down here. Okay, now in this step, again, I'm going to take the antiderivative of each piece separately. So start with the e to the x. What's the antiderivative of e to the x? E to the x minus, now what's the antiderivative of this? Again, that's one you have memorized. It's an inverse trig function. That's tangent inverse. The derivative of tangent inverse is 1 over 1 plus x squared. So what's the antiderivative of 1 over 1 plus x squared? Tangent inverse. Okay, plus, next term. Again, there's a number in the front, so you copy it down, and then you take the antiderivative of the rest. And what's the antiderivative of 1 over square root of 1 minus x squared? That's another inverse trig function. That one is sine inverse. Okay, then, next term. What's the antiderivative of sine? If you said cosine, you're getting confused because of derivatives versus antiderivatives. The derivative of sine is cosine, but I want the antiderivative of sine. It's going to be negative cosine. Because it's negative cosine, I'm not going to write down this plus sign here. I'm going to put a minus, so minus cosine. Okay, next term, so minus. What's the antiderivative of hyperbolic cosine? The answer is hyperbolic sine. So again, memorize those things, and it makes it easier. You don't put the integral sign anymore, so you don't write this down because we took the antiderivative, so that means you don't write that symbol down either. But once you write down the antiderivative, don't forget to put plus c. And I guess there's no cleaning up to do on that one, so that's the end of that problem. Okay, 2 more. Okay, for this problem, there's 2 things I want you to be careful of. First thing is, this is multiplication right here. Okay, so do not take the antiderivative of this and this separately. You can't do that. You can only take the antiderivative separately when it's addition and subtraction. So don't be doing that. Second thing is, if you look at this term here, you see something to a power. Don't use the rule where you add 1 to the power and divide by the power. You can only do that if it's x to a power, like x squared. But if it's a mess, some other mess squared, you cannot use that rule. Okay, it has to be x only as the base and the powers to be a number only. Okay, so what do you do? Well, basically, you want to use the rules that you know. Okay, I'm not going to give you a problem where, we don't know how to do it. You're going to use the rules that I've already taught you. So basically, the idea is you're going to rewrite it first. That's the key thing here. Rewrite the function first, and then find the antiderivative once you've rewritten it in a better way. So basically, what we're going to do is we're going to multiply this out. Once we get the answer, we'll multiply it by this. So we're going to completely expand it out, and then we'll go ahead and find the antiderivative. So let's start with this part. Let's consider this like side work. So to do this, there's a couple ways to do it. One way is you can write it out twice, and then you can FOIL it out. Or there's a shortcut formula. If you know the formula, go ahead and use it. So I'm going to go ahead and let you do the FOILing it out on your own. I'm just going to go ahead and write down what the shortcut formula gives me as the answer. So it's going to be 9x squared minus 42x plus 49. Okay? FOIL it out, you'll see you get that. Next thing, we want to multiply that by 5x minus 2. So 5x minus 2, here's the original function that we're finding the antiderivative of. So it's this. I'm not finding any antiderivatives now. I'm just multiplying it out right now. So I'm going to copy down the 5x minus 2. And then 3x minus 7, we just found out the answer is that. And I guess we have no choice here. We're going to have to FOIL it out. So if you do that times that, let's see here, 45x cubed. And then if you do that times that, it's going to be minus 210x squared. And then you do that times that, plus 245x. Okay. And then when you multiply those, minus 18x squared plus 84x minus 98. And I should combine like terms, so we have 45x cubed. That takes care of that one. And then we have this minus 210x squared minus 18x squared. That gives me minus 228x squared. Then we have plus 245x plus 84x. That's plus, let's see, 329x. And then just the minus 98, nothing to go with that. So anyway, after you multiply this whole thing out, you get this mess down here. Again, I have not found the antiderivative, just rewriting it. What's better, this up here or this down here? The thing on the bottom is way better. Why? Because it's all addition and subtraction. Here we have multiplication. We have no idea how to take the antiderivative when there's multiplication. Way better down here because it's all addition and subtraction. Okay, I have to do a bunch of erasing, but we're getting there. So now, again, you rewrite the function. In this case, you multiply it out, and then you find the antiderivative. Okay, so now what we're going to do, notice I'm going to write this symbol down because we haven't found any antiderivatives yet. This is just an equivalent way of writing the function they gave us at the beginning. Okay, and now we can go ahead and take the antiderivative. It's much easier because now it's just a bunch of addition and subtraction and numbers in the front. So because we have addition and subtraction, we can now do everything separately. In this step, I'm going to find the antiderivative, so I'm not writing down this symbol or this symbol anymore. The antiderivative 45x cubed, what do you do with the number in the front? You copy it down. And antiderivative x to a power, where the power is a number, you copy down the x. Increase the power by 1, divide by the new power. Minus, same thing here, copy the number in the front down, when you have a number in the front. Take the antiderivative of the rest. Since it's x squared, you copy down the x, add 1 to the power divided by the new power, plus, again, number in the front, copy it down, and then take the antiderivative of the rest. To take the antiderivative x, it's x to the 1, so you add 1 to the power, becomes x to the 2 over 2. And this is just a number by itself. Number by itself, tack on an x, minus 98x. And then don't forget to put the plus c. And I'll do some cleanup, but there's not much I can do. Basically, I'm going to put the 4 under the 45. You don't even have to do that. I'm going to put the 3 underneath the 228. But then the good thing is 228 over 3, you can simplify that. Here, put the 2 underneath the 329, and that's basically the end of the story. So you get 45 over 4, x to the 4th, minus 228 divided by 3. Let's see, what is that? I think it's 76x cubed. Let me see, 70, 140, 210, 28, yeah. Okay, plus 329 over 2x squared minus 98x plus c. And so that's how that goes. Important thing is right now, since we only have limited rules, we don't have a rule for multiplying. We're never going to have a rule that works all the time for multiplying, but right now we don't have one at all. You change it. In this case, you multiply it all out so that it becomes all addition and subtractions and numbers in the front, which we do have rules for. Okay, let's try one more. So in this last example here, it's division. Again, just like multiplication, we don't have a rule for division. Do not, very important, do not take the antiderivative of the top and the bottom separately. Do not do that. Okay, that is completely wrong. What you want to do is you want to rewrite the function so that we can use the rules we've already gone over. So you have to really know the rules. Know what we have and know what we don't have. We do not have a rule for division. So there's a few ways of rewriting this function. Since I'm going to rewrite the function, I'm going to copy this symbol down and we'll put the dx down. I'm not taking any antiderivatives yet. One way to do it is when you have a bunch of addition and subtraction on top and just one term on the bottom, you can put the one term underneath each of the terms on top. So I call that like splitting it up. So you can split it up into 3 pieces. So it would become 5 over x cubed, then minus, now you put the x cubed underneath the root, so square root of x over x cubed. Then it'd be plus, and then you put the x cubed underneath the third term, 8x to the 4th. So the x cubed goes under the 5, under the square root of x, and under the 8x to the 4th. Don't forget the dx here. Sorry, this term got a little ugly. Okay. Now, if I need to do any more rewriting, I will before I take the antiderivative. Then I'll take the antiderivative all at once. So for the first one, I'm going to just write the 5 on the side. So I'll write it's 5 times 1 over x cubed. Oops, I forgot the integral sign. See, we haven't taken the antiderivative yet. Minus this one here. We're going to have to subtract the powers. So let me go ahead and write it as x to the 1/2. And then x to the 3rd. So I'm rewriting the root as x to the 1/2. We'll come back to it. Let's go to the next term. Let me put the 8 on the side. And now, how do you deal with a situation like this? There's a few different ways. So let me give you one way. And again, if you know another way and it's correct, go ahead and do it that way too. But when you have x to a power divided by x to a power, you can write the answer as x to a power. And how do you get the power? You subtract the original powers that were there. So you're going to subtract the powers. What you do though, if you're going to do it the way I'm showing you right now, you have to do the top power minus the bottom. Always do top minus bottom. I don't care which one's bigger. Top minus bottom. So this would be 4 minus 3 here. Even if the top power was a 1, you'd write 1 minus 3. Again, if that's confusing you, I mean, try to understand it, but there's other ways too. I'm not saying this is the only way, but this is the way I'm going to go over. So okay, let's keep going. I'm still rewriting. I'm not finding antiderivatives yet. So again, same thing here. We have x to a power divided by x to a power. So you write x to another power. Where you subtract the powers, you got to do top power minus bottom power. And of course, this is x to the power 1. Okay. We're running out of room, so let's do some erasing. So, you know, x to the power 1 is just x, so I'm going to erase the 1. And then let's do half minus 3. Figure out what that is. So what is half minus 3? It's 1/2 minus 6 halves, so it's negative 5 halves. So I'm going to write equals, after some work, it becomes 5 1 over x cubed. Again, I'm still just rewriting. This is x to the power of negative 5 halves plus 8x dx. Okay, and now we're ready to go. It's a bunch of addition and subtraction, so you do them separately. And then we have numbers in the front. Oh, I guess we're not ready to go because the 1 over x cubed, because I would like that to be, it's not 1 over x. If it was 1 over x, you leave it alone. Since 1 over x cubed, I want to bring the power up. So if we want to move this x cubed to the top, I want to move it to the top so that it's just x to a power of a number, so I can use the rule for x to the power number. When you move it up, the sign of the power changes. It becomes x to the negative 3. So yeah, I should have done that earlier, but let's just change that to x to the negative 3. And now we're ready to find the antiderivative. Okay, a bunch of addition and subtraction and numbers in the front. So for the first term, number in the front, what do? Copy it down, and then you take the antiderivative of the rest. It's x to a power where the power is a number. So the answer, you write down x, and you add 1 to the power, becomes negative 2, and divide by the new power, negative 2. Minus next term. It's x to a power, so and the power is a number, so you copy down x, and you're supposed to add 1 to this negative 5 halves. That's going to give you negative 3 halves, and then you divide by negative 3 halves. Plus, and then again, this last one, number in the front, copy it down, take the antiderivative of the rest. Antiderivative of x is x squared over 2. Again, think of it as x to the 1, so you have to add 1, becomes x to the 2, divide by the new power, plus c. Notice I didn't write down this symbol or this symbol anymore because now I took the antiderivative. Again, do not take the antiderivative of some parts and not all the parts. Take the antiderivative of each piece separately all at once. So in other words, when I look at this, I realize that whatever function is in here is the exact same as the original one, just rewritten. But then when I look at this and I don't see this symbol or this symbol anymore, I know this is the answer now. This is the antiderivative. Only thing left to do, of course, is to clean it up. So let me clean it up. So I'm going to move this negative 2 this way a little bit. So I'll put the 2 under the 5. I'll put the negative sign in the front. Also, because it's x to a negative power, you should not leave negative powers in your answer. So I'll move it down, make the power positive. This one we will move. We're going to have to flip it. So we're going to flip this fraction. And also the negative sign will combine with that negative sign. And again, we have a negative power here, so we'll move that down. Here, we'll just move the 2 under the 8 and simplify there. Okay, let's see what we have. Okay, too much red. I got to erase some of it so we can see what we're actually doing here. Okay, so we're going to have negative 5 over 2x squared plus 2 over 3x to the positive 3 halves. So again, my idea is I'm flipping it, it becomes 2/3, and then when you move the x down, it hangs out with a 3 that was already on the bottom of the 2/3. Okay, and then plus, this is going to be 4x squared plus c. Okay, guys, I thought this video would have been shorter, but this video, the point of it is to refresh your memory on some antiderivatives and some antiderivative rules that you learned in Calc 1. And if maybe some of them you hadn't seen before, so then it's just some extra things to see. In the end, make sure you know how to find the antiderivative of everything that you see on this video. And then that way, when we find more complicated antiderivatives in Chapter 7 in Calc 2, you won't get stuck on these things over here. You're like, well, I know the simple ones, so now how do we do the more complicated ones? Okay, guys, that's the end of the story here. Study hard, and I will see you next time.